Hey everyone, it is morning. How's everyone doing? We got a few people watching right now. Stream should be good today. Cross our fingers. What questions are there? I feel like I readjusted my camera today. We're going to do a few camera fix right here. There we go. Much better. Hey, what's up, Kayla? Tell us if we had some buffering issues yesterday, so hopefully no buffering today. Please tell us if there's any buffering. I made some changes, made some fixes. What are you working on, Kayla? I'm going to load up R right here while we're talking about it. I reloaded the, look, you can see the screen brighten up right there. So my eyes, it's the morning. It's so early. R's loading up. How's everyone doing? It is the morning. I did fix it. And I think we are going to work on it. I think 2 out of the 3. I'm really excited for this new assignment. And the reason is, so there was a small change made here. I can bring it up and show the small change we made. So the reason the new assignment I made and I put out is because I felt like the old assignment, you could basically just ask for the answers. You could say to your friend okay, so what's the answer to this? I didn't feel like people were actually learning the material well enough. Let me do this. Transform, center, good, perfect. Now I'm perfectly centered. I moved it all around yesterday when I was teaching 201. So I redid the assignments this semester and I wrote ones that I really think get people thinking about things and also is more like writing a report. So let's go over here and take a look at it. We've got the updated assignment and let's do it. Let's take a look at the updated assignment. So I think a lot of people are going to be wondering, what is this assignment? What's going on with it? And let's see, we're going to make it nice and big right here. So, Kale, have you taken a look at the assignment? Is it working for you? How is the assignment going? I feel like everything's been adjusted. My microphone is so long right there. There we go. I don't need all that extra mic room. It's for 320, 201, you name it, Miranda. Right now we're just talking, you take any question you have, you can ask, and we will work on it. This is for all classes. Every class right here, you can ask, and we can work on the assignments. We're just talking a little bit about 320 right now. So I made a change right here to where it's 400. Good, I made the bar chart, and the still, I think, yeah. And it's not that bad, is it, Caleb? And so this is really cool because this goes over 320, 201. And so we got right here just executive summary, which you'll do in 201. Hey, what's up, Dan? So good to see you here. Thank you everyone for swinging by. Some mornings I talk to myself and I'm just like, no, I should have put bar chart and continue stable. Something you may not have known, Kayla, take a look at this. You can click right here and you can go to the different areas in this RMD file. So right here is like a table of contents. So you can, I didn't label this chunk, so I should have labeled it. This should just say, so it says these chunks will not be included when you knit. So we could say instructions, and then we put a comma there. And this is just instructions right here. About the association, let's do that. This is there a place I can go to where you're at? Yeah, no, this is a neat thing right here. And no, yeah, Dan, you can ask any question you have. Feel free to ask 201, 320, 474. I might not do as much 474 as someone's in 474 because I don't teach it this semester, but if it's quiet, I'd do it. I'd do some 474. So you're stuck on the third part about the association. So let's see right here. Where did I put the association? Boom, right here, right, Kayla? So we've got here task 3, which explains what task 3 is. And then we've got here the associate part of task 3. Now, something I want to point out, I'm just going to save this real quick with Control S, is when you knit this, well, one, it's going to have 2 issues with knitting right now. So I'm going to change the ID to, don't change it to 55555. Interestingly enough, if you look at what this code does right here, that's not a real student ID, just in case anyone was like, Brian, what are you showing someone's student ID for? Not a real student ID. This code right here, if you run it, my sample not found. Oh, please tell me I didn't break it again. What is going on? So let me run the code by code, because it's supposed to work. Okay, everything's loaded there. Let's run it line by line. That sets the randomness. That sets the seed. That loads the data. That loads the amount. I think I didn't have reg class loaded. That takes your sample size. There we go. And there we go. And then you can look at the, yeah, that's just how many you have. I guess I could have removed that. So everything's good. I just didn't load in reg class. That's why it broke. If I go back up here and look at the error, it's probably, yeah, here it is. The first error was hit previously because reg class wasn't loaded, so it couldn't get survey 11 data, and then it couldn't make the sample size, so I didn't load the previous chunks. This button right here, and Kayla, you probably know this, what does this, it literally says what it does. This runs all chunks above, So if I click this button right here, it'll run every chunk above. The only thing, and I want to point this out, when you first work on this file, I think most of the code will run except for one thing. I could have hashtagged it all out, but I was worried people wouldn't know how to unhashtag it. If you want to knit your file to begin with, then you need to hashtag out all of this. I'm using Control-Shift-C, but you do need this later on. Like, this is important for doing an aggregate function. So I can hashtag that all out or unhashtag it with Control-Shift-C or Command-Shift-C. So I'm just going to hashtag it right now. I'm going to save my file. I'm going to knit my file. The reason I'm going to knit this to a web page is it just knits quicker. If you notice, there's basically nothing in this. So one thing I want to point out right here that's huge is some of these chunks have options on them. Did you notice this, Kayla, where it says eval equals false, include equals false? And we haven't had any buffering issues yet today, have we, everyone? We're good? Yesterday was a fun day with buffering. No, it's like we even got dislikes on a 201 video. 5 people disliked it. They probably like, dislike, I'm leaving. Oh. So I think we're good today. I think we've been streaming well today. Get the volume all the way up. Tiny buffer. Good so far. Okay, we're going to Lucy cross our fingers. So we'll tell us if there's any issue. There was one skip ramble. Okay, one skip. Just one little skip. Suddenlink, do your job. So eval equals false, include equals false. I might change like the bit rates and stuff. I might actually try streaming 720 if the issue persists. It'll change how much I'm uploading to YouTube. But just tell us if it's good throughout, because I'm just hoping when we do class today, because I'll be teaching 2 classes, everything goes smooth. So did you notice these right here? And then we're going to do the associate function. With these right here, Kayla, these will control if the chunk is evaluated, and it'll control if the chunk is included. This is why when you knit, you don't see these chunks that have include equals false. So this chunk right here was included because it didn't have an include equals false. I could change include equals true, and you can see what happens here. So if I put include equals true on this when I knit it, you will see this included in here. So there's the instructions. We don't want to do that. We don't want to include those instructions. Someone's not going to be reading those. You can delete out anything you want afterwards, but it's just easier if you're going to put instructions or something to have include equals false. Include is by default to true. You can change a lot of these very quickly by going to the options over here and just changing things like this, which I'm not really trying to change these. I think it just is set to the default value. There we go. So that's the default. That's warning equals true, and that's warning equals false. And then the middle ground is the default value. So just understanding what these different chunk buttons do, how they control what the code does. I've never even used custom figure size, used page tabs. I know what these do, and I know what this does, and then there's the name of the chunk. So if I wanted to call this like task 5, it's just going to change that area right there. Just understanding, here we hit revert, cool. Didn't want to do those changes, just kind of want to show off what that does. And you can write all this here, or you can just control most of it in here. Show nothing, don't run code. That's what I chose for these. So that way it would just show nothing and not run the code. So when we do the associate function, here's the big thing. The associate function is what format? We should know the format of the associate function really well. There's a basic format. We'll be covering this at the very end of class today. Yesterday, due to buffering issues, we barely got to it. I wish we had done a little bit more on it. We mentioned it and we didn't do enough examples with it, but we'll do a lot on next class. So what is the format for the associate function? People might not know it, so I'm probably gonna have to say it. The associate function, which is inside of reg class. So, good. So it looks super complicated, right? Like if you look at this right here, you're like, oh my gosh, what's going on? So Kayla, thank you for saying like you haven't seen it. Let's throw some points out. We haven't thrown points out today. Kayla, thank you so much. Saying, Brian, I have not seen that. I do not know how to use this function. So can you explain how to use this function? That would be very helpful, Brian. Let's talk about how to use the function. So the function associate is going to be y tilde x comma data equals. So there's other ways to write the function or write the format of it. This is my favorite way, and it's very important is for a later function that we use the y tilde x comma data equals format. There's things I've got so many projects that are not vital, like improving all the graphics in reg class, and Dr. Petrie and I have talked about that multiple times, but that's not like a must do. There's things that I want to do, and then there's things that I have to do. And the things that I have to do take priority over the things that I want to do. So y tilde x comma data equals. So let's just look at what we need to do. create the full output for the associate function using both variables you picked. So we've got here class. So class is a variable, and then we are choosing another categorical variable. So we need to choose another categorical variable. Let's take a look at our data right here. So we're going to see if class level, which is the X variable, let's go to another variable. And Kayla, I want you to tell me another variable from our sample we could use. What is another variable from from our sample we could use? I need to disappear. What is another variable? And let me be very specific. X30, you might be right. Yes, morning person. That'd be interesting. Let's do that. Now I'll show you a trick right here. Here's a trick. I'm going to go attach my data, my sample, and this attaches the data. So when I type X30 here, it auto-completes. So that makes the vectors available in the global environment. Oh yeah, sure, let's do it. Let's analyze this one. And I'm gonna show a few errors maybe, but this makes, and you know what, truthfully, since it's attached, this will be interesting. I've never tried this. I don't, ignore what I'm doing for a second. Let me decrease screen size because it'll give a graphic error if we have the screen too large. So we're gonna, I'm wondering if this will run. So when you attach, the function attach, which I just ran, makes it so that the vectors right here, if I type x06, it is now available in the kind of global environment, even though it's in a data frame. And it is able to run that. So truthfully, since I've attached this, it does work. Now I would probably put data equal, I think oh, and then the screen just blinked. How bad is it buffering, everyone? And my screen just literally blinked. I tried calling Suddenlink last night and I couldn't get through to them, and I'm gonna try. On a scale 1 to 10, how bad's the buffering? Good for now? Okay, I need to talk to Suddenlink. We pay really well for our internet, and I need to, better after a refresh, okay. Need to call them right after this stream and say, hey, are we having issues in our area? Because I called last night and I couldn't get through. I was on hold for like 40 minutes. I was like, okay. And then I made some changes with the router and stuff. So, okay. So what do we have right here? So don't worry, I'm very, oh no. Oh, the fun of using the internet, right? Okay. So taking a look at this graphic, Kayla, what do you notice about it? Here, I'll vanish again. What do you notice about, oh, this is interesting. And there's a big thing going on right here and then here, and this is good for 201. This is good talk for 201. You've got here, then here, then here, then here. So how would you just describe this? This is key to like, look at this, and it's kind of near a nice number. And then you look at this over here and you say, okay, that with this and with this and with this, what do we notice about this? And we'll pull up the table here and take a look at it. What do we notice here with the table? So better yet, we can look, wow, look at that. That's perfect. And can I get both on the screen? There we go. So hopefully everyone can hear what I'm saying. Look at this, and then look at this. And then I want for people to understand what this is as we look within here. Yeah, I like that. The way you described it, Kayla, and then make sure to mention these numbers. If I'm describing this, I would say that, freshmen kind of go against the trend with 75% of freshmen saying that they are not morning people, opposed to 25% saying they are. The percentages then go more to about a 60-40 split, with sophomores being the least likely people to be. Oh, you know what I didn't do? I didn't order this. And when I order it, it might change how the graphic looks. Okay, Petrie's function does not take into account order, which is really sad. Oh, maybe I just need to reattach it. Did it reorder it now? I think it did, which is good. Yes, it did. Okay, good. So I ordered this for you, and I didn't run that code. There's a code I ran previously that will order them. If you're wondering what I'm talking about, here's this code right here where I ordered the variable. I'm just doing this a little bit out of order right now because I'm just hopping down to this section. But now somebody's class level has been ordered, and you can see, we generally see people are more likely to be morning people the higher up they are in their education. We don't see much of differences, though, once we get to like sophomore, junior, senior. And here's the percentages of people who are morning people right next to the graphic. We're only 25%, 35%, 43, 37, 38. I mean, it basically goes to about 40% or so are morning people from 25%. It never, and I would mention these numbers. This is key, especially this one's so easy to mention, to say only 1/4 of freshmen are morning people, opposed to juniors, which have 43% being morning people. This is the biggest difference we see, but the difference is not as large between sophomores, juniors, and seniors. It's only really freshmen stick out. But here's the thing, and this is what we'll talk about a lot, and this is pretty much the full analysis of this graphic now. What do you notice right here with the p-value? The p-value is so very important. So what's the deal with this p-value, and what does it tell us? Does anyone know 201, 320? Does anyone know when we see this p-value and it's high? What does the p-value tell us? What does this p-value tell us about that graphic we were just looking at? That everything we see could just be due to what? And exactly, Kale, it's not statistically significant. That's exactly right. That means the differences we observe in this graphic are likely due to random chance. So you can actually see the p-value over here on the far side. Let me pull up snipping tool. What's up, Charlie? So good to see you here. It looks like we're not buffering again for a moment. Yay. So if we go right here and we do the following, this is the p-value. This is the p-value right here. So how much of this curve has Brian shaded in? How many or what percent of the random permutations, which is at the very end of class day, are as extreme or greater than our observed result, which was the 2, which is basically 3. If you look at where this is at, this is basically 3 right here, which is this number right here. What percent of the random permutations are as extreme or more extreme than our observed result, which is technically 2.99. So this is technically at 2.99. Right here on this is 2.99. That is our observed result. So there's our observed discrepancy, and then there's the p-value. So 60% is actually below it. It's very hard to see the little tiny dot. So this is 60%. Worst percent ever. I don't think I can use the stylus to draw on this. This will be life. Oh my gosh. Whoa. I did not know I could use the stylus. Yep, this is 40%, and I can totally draw on this now with the stylus, which is completely life-changing. Oh my gosh, why did I not think of that? I have a stylus. So now, whenever I screenshot and I have to draw on it, I can just say like, oh, this is the p-value right here. Maybe I knew this. Maybe I knew this. And then right here is the 40%. And over here is the observed result of 2.99. So this is the observed result. Does this make sense, Kayla, right here, that we are saying our observed result is likely by random chance? We can do one that's not likely by random chance, like probably if someone is satisfied with their weight. That one, I'll do one that's really obvious right here. This is one you won't be doing. But let's show a difference that is unlikely by random chance. We're going to take somebody's gender, which is EXO2, and we're going to do if they're satisfied with their weight. It's just this one will come out that it's unlikely by random chance. And I just want you to look at these differences. Now, I haven't told you the p-value yet, so let's go ahead and screenshot this so I can draw on it. But I want you, if you're watching, to figure out the p-value for this. This is my favorite test question to ask people. So I always like using this one as a test question or something like it. You're like, Brian, you didn't use exactly this one as a test question. I know I'm showing the p-value, but can you figure out the p-value on this one? Here is our observed result. That's what we observed. And if you look, you can tell the value of the observed. And then what is the p-value for this going to be? It does say that. That is correct. And that's because over here, there are no permutations. There's no permutation results. So the p-value is 0. And what's interesting, Kayla, so here's a very interesting thing. P-values actually technically can't be 0 because if something occurs, it must have a probability of occurring, and this did occur. But what we're doing is we're simulating a p-value. So we create these random results over here. And so with these random results, we see how many of the random results are as extreme or more extreme than our result. So if we go back to our previous example, I'm going to make this so small that you can't see the p-value. And now let's do the previous example, but I want you to tell me what the p-value is. You ready? This is where if you see this, you'll really understand the topic. I want you to tell me what the p-value is now. Oh no, don't look. Don't look. It was not supposed to do that. Don't look. What is the p-value now? What is the p-value now? So think about how this estimates the p-value right here by creating these random permutations. Random permutations means the data's just been shuffled around and we create random differences between it. Like this is by random chance, this is by random chance. Here's our result. So what would the p-value be here? You might have saw it. If you looked over real quick, you would have seen it. What would the p-value be here? And if you don't know the answer, once you hear it, you'll be like, okay, I get how it's found on that graphic. Yeah, you saw it. Okay, don't look. Close your eyes. I'll tell you when you can reopen them. You ready? Yeah, sure. Don't don't look. Okay, go ahead. What's the p-value on this one? What is the p-value on this one? As long as that one is over to the left of it, we should be good, which it looks like it is. It looks like this one is to the left of it. So the p-value is the probability of our result or results more extreme happening by random chance variation. So these permutations are by random chance variation. They're completely random. Like we just mix up the data and we see the differences that would have occurred by random chance. So what would the p-value be for this? And I did 5 permutations. So I made 5 random permutations. There's permutation 1, 2, 3, 4, 5. So what would the p-value be for this? If you get this, you understand how to do random permutations. At least you understand like how we're getting the p-value from them. And this is a big concept for 320. Hope we're not buffering. Every second there's a pause. I'm like, oh no, please. Okay. So the way to figure out, here's the definition of it. You ready, Kayla? I'm going to repeat the definition. I think you'll see it. The p-value is the probability of our result or results more extreme occurring by random chance variation. So what is the probability of our result or a result more extreme? Here it was 50% with 2 permutations. So now let's look at the probability of our result or a result more extreme. Now, our result is not this result. Our result is the red line, which is above this result. So what's the probability of our result or a result more extreme? So Charlie, perfect job. Do you see how Charlie found that 1 out of 5? So Charlie is correct that the p-value is 20%. So if we were to do it again, and these are random chance, so now I want to do one that's, okay, let's do this one. This one's a nice, easy one to get. What's the p-value here? So if you see what Charlie did right there, you'll be like, okay, I get it. Like you'll see how to get it very quickly. So what's the p-value here? There's 5 permutations. What would be the p-value here? You see it. So the p-value is going to be right here. There's the p-value because there's 60% of the random permutations were as extreme or more extreme than ours. So what if I make this 100? So what would you, let's make it easier with 10. What would you tell me with 10, like 1, 2, 3, 4, 5? What would you tell me right here that what percent of the random permutations had differences that were what to our result? So discrepancies are created at random chance. And you'd say that like random chance would create discrepancies as large or larger than our result 50% of the time. So do you think our result could be by random chance? Like this discrepancy we have up here would occur, or something more extreme than our discrepancy would occur 50% of the time due to random chance. That's like a 50-50 shot that what we have here was just created via randomness. Does that make sense, Kayla and Charlie? That this result up here could definitely just have occurred by random chance. If you were to mix up the data just randomly, you would get discrepancies as large as it. So if we do 100 permutations, like we're just shaking it up 100 times, and you see, that's why it creates an estimate, because every time the permutations are what? Why do we get a different estimated p-value? Every time these permutations are going to be what? Every single time those permutations are going to be what? If you notice where our result is doesn't change, it's always at 2.999 because that's our observed result. Our observed result is in the same spot, but every time these permutations are just whatly. They're just completely what? Every time we get blank permutations, which are just mixing up the data. Random, exactly. So you know what's interesting? If you increase the permutations to a really big number, what's going to happen to the p-value? Is it going to be more random, or is it going to stabilize around what the p-value is probably close to? If I make the number very big, look at this p-value right here, which has more accuracy now with a bigger number. It was 0.3847. So then what's going to happen when I run it again with a very large amount of permutations? 0.3847, and now it's basically 0.39. Yes, exactly. And it's stabilizing. Nice job, Charlie. You're doing excellent, Charlie. You don't need to be in the class. I think once you start to see the topics a good bit, you're like, okay, we're just using randomness to estimate p-values. What's pretty interesting is this is a very advanced way of doing p-values. This is a way of doing p-values that we couldn't do in the past, because if you look, I'm on a supercomputer right now, and it's literally taking this computer 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000, 6, 1000, 7, 1000, 8, 1000, 9, 1000. That took the computer 9 seconds. You know what's even cooler? Watch this. Sys time, let's store here time, and let's go here, systime minus time. Watch this. It takes, wait, oh, is it mad? Did it not do it? Oh, it's because of the input. Okay, so then we gotta do it this way. You ready? It's because it wants an input, and it's taking that as the input. That's a bummer. It took me 7 seconds to complete that. So I can take the time before and the time after, and that was close enough. I had to press the buttons too, but it's taking my computer 7 seconds to run this right here. You don't need to do the system time stuff. It's just something that you can do. But it took my computer 7 seconds to run this. Imagine running this 10 years ago, 20 years ago, 30, 40, 50 years ago. You couldn't do these statistical techniques, and you couldn't create these estimates of these p-values this way. You had to use more classical approaches. And that's why I've seen a lot of people talk about how we do statistics now. We can just kind of brute force do statistics, because it's like, oh, you don't need to find the answer. You can just estimate it. And maybe you've seen that with mathematics, Kayla, where people, you can just use an algorithm to run through all possible answers, and you don't need to actually find the answer. You can just, and so it shouldn't change anything with the buffering with my camera, because I'm still pushing the same amount of video through to YouTube, still 1080 video. But does this make sense what this graphic is talking about here, Kayla? I'm going to remove this just in case someone thinks they need to put those things on there. Let's see if there's any other questions you have about the graphic. Short answers, blah, 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 blah. You need to talk about the p-value, which is a big thing we talked about right here. The p-value is telling you, so I'm basically explaining the p-value right here. The p-value is telling you, you can use the attach function. If you use attach, you no longer need to, I think for the later one, you change the permutations. If you use the attach function, you no longer need to put data equals. It might not be the best to put the attach function. Just as long as you know what you're doing, it's good. You just want to make sure you don't get in the practice of just copying code. Like when you write the attach function, you need to be like, okay, what does this do for me? Like, what does attach do? It takes all the vectors in the data frame and makes it so you can access them without doing the $sign. So any vector, I could go right here and type x03, and it would fill it with height, and it's going to give me all the height. So if I think I can detach it. I rarely do this. But if I detach my sample, now if I go here to x03, it still shows it. Do I need to detach it again? There we go. Or is it still going to autocomplete? I think I had attached it twice. So if you look back, I think I ran it twice. But if I have it attached, let's reattach it. Now when I type x03, it gives me access to it. If I detach it, now when I type x03, it does not exist. So knowing what the attach function does, that it takes all these, would I need to attach function? No, one time. Once you attach it one time, it attaches to the whole thing. That's a really good question right there. Once you attach it, it attaches and you have access to it. I don't know, some things Petrie likes and doesn't like, and it's all like, what's best practice? It's very iffy on like, what is the best thing to do? Have we only had like the one buffering issue? Or have we had other buffering issues? Please tell me if there's any buffering issues, because I need to like figure out how much I have to address it. I think we've only had the one. Ooh, tell me if they occur. Give me more heart attacks. No more? No more? Just one heart attack a day? One heart attack a day keeps the doctor away? No heart attacks. Bad. Keep asking questions, Kayla. You're doing an amazing job. I definitely want people to check this out. But is it making sense what you'll be doing? Let's make sure we answered all the questions, generally speaking, right here. Unless you detach it. I wouldn't detach it. So create the full output for the associate function using both variables you pick. Make sure to include the short write-up about the statistical significance and what this means. Because for this one, we already talked about the contingency table up above. So when you do the contingency table right here, create a table and talk about the marginal versus the conditional distributions, let's show this right here. We can take our code that we've written right here, y tilde x comma data equals. I don't think you can put it into the table. Here it is right here, and I put the chunk for it. Here's the contingency table chunk. We need to change this code slightly. We're going to put data equals and my sample. And then we're going to go right here, and it needs to be, there we go, let's do that. It's giving the graphics error. Let's remove the graphic. It's a warning message, technically. X06 class not found. Data equals. Oh, associate. Oh my gosh. Table. There we go. What? What is going on? X030, morning person. Oh, I know why. So much fun. So many syntaxes to remember, and that's why I like showing them. You know what? I swear you can do a table this way with formula format. Have I lost my mind? No, you can't. Apparently you can't. The interesting thing is I rarely to never have made it, like with the associate function, you get everything you need. And we need to put the comma here. There we go. So with this, and there might even be a better way. What's really cool, Kayla, and I'll show you something right here. You are more than welcome to look up code online and find your own code. So I might find a code here in a second that makes a really awesome contingency table. Is there a contingency table? Contingency, no. So this is the kind of table we're looking for. Did you do this originally, Kayla, right here? We're making this sort of table. And the reason I don't usually think about making that is because this is all made via the associate function. If I switch the order of the variables right here, we will get the same table we have. I rarely have to use this format to make a table because look at this right here. If you run the associate function, you get the same output. What is it mad about? X06 not found, attached, there we go. Invalid graphic state, that means that's too small. There's so many errors you can run into. So knowing each of these errors, or at least how to handle them, is pretty big. This is why do not start late on this. If anyone's watching this, any of these errors we just hit right here where it says like invalid graphic state, that could stop someone. But meanwhile, I know because it means this box is too small to make the graphic. Someone to run into this error right here where it says it's not found because I'm using the attach function right here. So do not start late on this. Please, if you run into an error, you're like, hey, Brian, it says it's not found, then probably the easiest thing to do right here is just to always write data equals. There's no reason to really not write it. It's just like an extra thing. Is this all making sense, Kayla? I figured this video is probably going to help people to go back and review and see how I'm doing the code and to see how I'm analyzing it. I always want to put pretty much the answers out there for people, but kind of understanding what the code does and what each argument does. So we have y tilde x, which is just the variables we're using. Permutations is controlling the randomness and like how many times we're doing random permutations. And then data equals is where our data is at. I'm gonna do one thing real quick because I want to look at some fun stuff. Let's see here. ggplot contingency table. ggplot is a graphics package that does amazing graphics. And I'm gonna see if ggplot has a contingency table in it. So I'm going to see, do they have a contingency table? And is it just prop table? Well, that's not that awesome. Let me look up contingency table in R. And if you have questions, ask them. Contingency tables in R. We get one, but I really want it to look nice. And I want to see if anyone has a nice contingency table created. They're just using table. There's so many packages. That is not. How to create introduction to contingency table. Ooh, this is from December 2019. Here we go. Is it just going to be, okay, wait, we got something. They're doing prop table. Prop table. Okay, let's look at that real quick. Look at this real quick here. Prop table, its base function. Wow. So prop table, probability table. And then where is a bivariate display formula. Oof. So I'm just looking at how they make it. Oh my gosh, they make this so complicated. It's just, can we put in the two variables? X03, that's height. We don't want to put that in. X02 gender tilde X03 30. See if it runs it. Need to look it up. Let's see what people are saying in the chat. Yes, could you show how do you switch between the sections easily? So are you talking about, I'll worry about the prop table here in a little bit. Are you talking about this right here, switching between these sections, Kayla? Are you talking about this help right here, like when you switch between, yes, clicking this right here, you can just go down to a certain task and you can just jump around the assignment to anywhere you want. Like, let me jump to the executive summary where I'll write the executive summary. This is pretty huge right here. People should know that this is just the table of content for your tasks. The executive summary is pretty big. And what I want people to realize is you're basically just writing a report. You're basically just in a Word document the whole time, and you can write your report out in this area. Like you can write executive summary. And I think there's spell check. Spell check? There we go. It's doing it. So what's really nice is they didn't have spell check inside of R. Hey, what's up, Jacob? So good to see you here. They didn't have spell check inside of R for a long time. I think spell check is one word technically, but spell check now exists. This is just an area where you can write everything out, and we should be able to knit this. Do we have an error? We don't have an error. Good. Always try knitting your document. If it fails to knit, let me know. And you see you get all the output. So we get all the output here. We need to talk about it though. And so you get every little bit of output when you knit this. You can knit it to a Word document. Let's knit to a Word document. And Word document's coming up. So now it knits to the Word document, which is what you'll submit. And you see you can come in here and just edit your output. So if you want, you could do all the coding in R and then come outside of here and talk about the output. So you could delete this right here if you want, because we don't really need this. But I highly support people going and see, I don't want to be in that area. Really? Sure. Oh, that's fine. This is where I am going to write my report. So you can just write your report as you normally would. You can do all the work inside of R, but you could also, if you want to write your report at the end of it, you could just go down here and say, this is where. So this is very important right here to understand that it's going to turn this all into a Word document for you. You don't have to worry about editing it though 100%. You see it's doing this right here, but watch this. Here's some interesting things. If you go around this and you put stars, watch what happens when I knit it. But you don't have to do this. You could do this in Word. Once you're done with your document, you could just go and edit your Word document. And I think too many people spend time being like, oh, I want this to be, see, that's italics, I think, right now. Yeah, it's in italics. It's double star is bold. So let's go around it again and put a double star. You see it changes colors again. And now when we knit, it should be in bold. So even I have to like review, okay, like a bold is double star, all these different things you can do. We go to the very bottom of the document and it's now bolded. So you can do this while writing your document. You could easily bold something. You could italicize it. I thought it was underscores italicized it. Maybe it is underscores also. But double star is bold. But you don't need to memorize all these things, because if you don't want something bold, you could go right here and just remove the bold. You will be submitting this document right here with all the output and everything. You see, here's my executive summary right here. I just wrote executive summary spell check. So you will be just knitting your document, submitting it, and turning in this report right here. Is this making sense, Kayla, what you will turn in? You'll turn in this full report right here. It'll have the output from what you're doing. You could probably remove, like if I'm turning this in as a report, I'd remove this. I'd remove that. I might make this a little bit bigger. Oh, see, I'm grabbing the edges. I thought it would keep the edges consistent. This is not so important, like these small little changes. No one else has a question? Yeah, Chunk 14. Also, can I send this to you before Sunday? Yeah, exactly. Please send it to me before Sunday. Be like, hey, Brian, does this look accurate? Okay, let me ask a big question right now. Can you see the rubric? Can you see the rubric? Like, if you go as a student, does it show you the rubric to look at? Let me try to pull that up right here. And then we'll go look at the chunk here. This is a really good help session for 320. And I'm glad the internet's been doing much better. Does it show you the rubric? Because I think that'd be so important to students to see. And I want to make sure, especially later today, people know that there is a rubric. There's certain grading guidelines you will have. And this is the first time you can see the rubric. Awesome. This is so huge. Knowing the rubric, can you see the way the points are allocated in the rubric? Like, can you see the descriptions of like, didn't do this, didn't say this? Because if I was a student, and so here, I think, yeah, this is probably, do you see exactly this, Kayla? Is this pretty much exactly what you see when you go to the page? Yeah, Jacob, thank you so much. Yeah, it's only 201. And I think it's pretty cool that you can actually make web pages with what we have. Exactly this, perfect. This couldn't be any more clear on how you will get your points. Because from what I understand, and this is my first time using a rubric, the grader is literally going to choose one of these options. So when you look at like opening paragraph of assignment that explains to the reader the full report, if you go through the key ideas and you summarize what happens in your report in an opening paragraph, you get the full points. If you miss a few things, like you're not really mentioning the numbers, like you don't give numeric details, like not enough numeric backing in the report, you should give the numbers, you should quote relevant values to, tell the reader what's going on. They're going to assign small issues for this portion. If you don't really give a full report, you just kind of go through it, they're going to give you 5 points. So this is kind of like C work or D work. So you get a 50 on it, but it's like this was not good. And this is just if you don't have it at all. So pretty much any effort that's not, I should have maybe put 2 points here, like minimum effort, but like just a sentence given or something like that, like executive summary given, but doesn't, yeah, it's just hard. It's like, how many areas do we need? Random sample used. If you use your random sample, you get the points. If you don't, bar chart. So it should be pretty clear if you go through this when you look at each section and how it's graded for a total of 100 points. But it should be pretty clear. I would go through and be checking this off and making sure I do these parts, because you can see you mentioned but not explained. Oh, did I not? Oh no. Oh gosh. Did I delete one of the areas? Oh, I gotta go back and edit that. I spent a good bit of time this weekend making this because I wanted to make it as clear as possible on how you'll be graded. I'll fix this one right here because this should be the full points. I think I meant to have that be like 2 points or something. So Kayla was wondering about section 14 on this. Here, let's close this out. There's another error you can run into if you try to knit to a Word document and you have the Word document open. It might be, or am I just totally crashed it? Or is it just mad? See, now it's just doing that. So yeah, it looks like it got mad because I think the Word document's open. So you can run into all kinds of errors. But start early. If you run into errors, let me know. I thought that would make an error. It just made a different error than what I thought. So let's go to chunk 14 right here. What were you wondering about, Kayla? You said, if no one else has questions, can we look at chunk 14? Can I send you? Yes, so chunk 14 or chunk line 14? Let's go to chunk 14. Chunk 14. Analyzing quantitative Ys. Great question right here, Kayla. This will be one of the last lectures. So let's go here to analyzing quantitative Ys. And here we are. So what we have here is quantitative Ys. So we need to decide on a quantitative Y. And the first thing we're going to do is create a visual display for a quantitative variable of your choosing. Okay, this is great for 201 and 320. What visual display could we create for a quantitative Y? So let's go and look at the Y values right here. What visual display could we create for a quantitative Y? We need to know this pretty quickly for 320, 201. So what visual displays? And I'm going to show the cheat. Here it is right here. What visual display could we create for quantitative Ys? Here's all of our visual displays. What visual display could we create for a singular, just one variable, not multivariable yet, not bivariate, but a singular quantitative Y? What displays could we make? Some of them I'm not so favorable to. A histogram. Probably histogram is going to be our best bet. Great job right there, Kayla. Histogram is going to be, just a nice, simple histogram. Someone could argue a box plot too. Box plot, histogram, either or is good. So which variable do you want to use, Kayla? Which variable would you want to look at? And then we're going to look at it. We're going to compare it on Greek life. We're going to look at the association with Greek life. So which variable? So we can basically be working on yours right here. It's a really good review for anybody and really good help with the topic, with the assignment. My goal is that everyone does their own work and everyone kind of understands it. Everyone gets practice writing a report, because I just felt like the other assignments were a little too, like, there's right, wrong answers to them, and people just get the right answer and just move along. But I want people to be like thinking this through and more like, okay, so I need to create, like, it doesn't say make a histogram. It says just make a display of quantitative data. We display data to begin with. So what variable could we display in a histogram? I can scroll through more, but you can just say X whatever and I'll graph that one. So which variable would we want to display? Oh, there's so many interesting ones we could do. X24, what's X24? How much people sleep per night? That's pretty interesting because we're going to compare it over Greek life. So here's how much people sleep per night. That's the graphics error. Don't worry, it's just saying warning. And it shouldn't do it anymore now. Yeah. I found if you remove the graphics, you don't get the graphic warning. It's do try catch, which I hate that. I just hate that error. Let's go here to hist. We're just going to put that inside of there. But also, once again, I do have this attached. Probably a lot of people are going to run into this is not working. So I'm going to go to my sample because I realize people are going to not attach it. Attach is just such a nice function. So now we get the autocomplete there. And here's the distribution. Now, when you look at this, this is a little bit skewed. Let's look at it. This is a little bit skewed. So since this is a little bit skewed, what might we decide to use? Since it's a little bit skewed, which I think we later on start talking about up here, briefly describe the shape of the distribution. It is unimodal, little bit skewed to the right, and maybe there's some outliers, but I would say unimodal, a little bit skewed to the right, and that's going to clue in on, because that's why we talk about the shape. Nice job right there, Kayla. And that's 201 talk. So if 201, if you're listening, you always look at the shape, then you look at the center, then you look at the spread. And so now we're going to create a table comparing the means. And here's what's really great is this code is already given to us right here. I'm going to uncomment it out with Command-Shift-C or Control-Shift-C. It originally starts out uncommented. And then we're just going to take sleep per night right here. And that's going to be the Y variable, not like that. We're going to put sleep per night right here because this is the Y. And then I called this variable Greek. So I've already renamed it for you. So you can just write Greek. Here's it renamed right here, and that should be in our data set. Either way, I'm calling the data frame right here so it knows where to go. So now we can look at the distribution of the data, and I was going to try to change there's a way, I'll show you. If you don't like how long these variable names are, you could go right here. I guess I should have done this. I don't know. So this is the extra mile. Greek, mean, median, standard deviation, IQR, and then let's go call it table, and then let's go names, go table. Oh, is it only got those two names? Ooh, that's gonna be interesting when I do this right here. Let's see what happens. Let's see. Let's store this into names. Can we do call names instead? What's call name going to say? Because I should give all those names. Ooh, okay, let's find out. Let's see what happens when Brian stores the names. It's mad. Is there only two length right here? Greek. Oh, I know what I want to do then. Let me try this. Let's do this. This is why I just didn't want to create a whole mess of code right here. Table as dot data frame table, and then names table. Okay, nope. We're just keeping it. Okay, let's bring it back to where it was. Okay, we're just keeping this. I'm like, is that not a table? Why is the aggregate? Anyways, okay. You know what? Okay, I know the fix. Actually, I know the fix. I just figured it out, like literally in my head in that moment. Let's put this blank right here. Let's do this. And so now let's store this. Let's try this. Okay, let's not put this. Here's the fix. So this is advanced stuff. And now let's run table. There we go. Because what it's doing is it's appending the name onto this, It's appending whatever name I have onto the name as I gave it right here. So all I did was put in a blank name. Does this make sense, Kayla, with these steps that I did right here? It was taking what it was ever in this second position right here and appending that onto here. So when it said the name of it was X24 Sleep Night, it's just appending this right here. So I was like, okay, just make that a blank vector or make that a blank character. And so now I rewrote the names of the table, which is what it has up here. I wanted the first one to be Greek and the remaining ones are going to be this. And I already have these names for these. So now when I overwrote the names with those and I reprinted the table, we get the following. So I like this way better. I don't know. When I was working on the assignment, I was like, okay, I just don't want this mess of code that people are going to be changing. And this was already crazy enough. And I was like, let me just, and I don't know what variable you're going to use. Well, I guess it doesn't matter because this is the X variable. So with this right here, and I guess it is important, if we really want to be nice, we could do sleep, nightly sleep. Do this, nightly sleep. So now I just don't like that. I'm much better with this. I'll explain to the reader what the variable is. So probably tell people what the variable is that you're working with. Last but not least, you could go here to round. This is just nicety stuff. And you could round your table. Oh, it doesn't like that because it's categorical. Really, table? Really? Well, let's just print the table. So with all this right here, what do you notice? We have right here the median for Greek life and the median for, non-Greek life and Greek life. What do you notice about these medians, Kayla? And this is the big thing we'll look at in this associate output. Can we write a title for the table? We would, when I knit this, so here we'll look at how it looks when we knit. Are we crashing again? 2 seconds. Class isn't over, but this keeps doing this. Let me close out of the Word document because it's getting mad when it tries to save. Let me try knitting it again. See, now it likes it. If you try to write when a document's open, it gets all kind of mad. Put the code you're thinking about in here. So now we have this table down here. So you could go right here, like this is the easiest thing to do. And you could just put table of Greek life versus our nightly hourly sleep. You could comment this out. Like technically this is no longer code, so you could put a comment right there. And this would be perfectly fine. Like if someone wanted to rerun your code, you could add this in right here. And you could especially in your Word document go in and do like this right here. So that would probably make it really clear to both a coder and a reader what this table is. If you wanted, you could also do things like this right here. Nothing wrong with editing your Word document. I don't think I tell people nearly enough that you don't have to do it all in the coding. You could go in and edit it in the Word document afterward to make kind of it look better. You could also edit out the code if you technically wanted to, because we are just grading the report. So you could take and remove, I probably would, well, not that all. I would probably take and remove at least this. This is just nicety stuff. Just think about, you just want to make a nice looking report. Does that make sense, Kayla? Like the goal is, we're not going to be super harsh on like, oh, you left code in, oh, you did this. But we want that you go down here then and explain when looking at the medians between Greek life and non-Greek life, there is no difference. Both groups reported a median hours of nightly sleep of 7. So, and you could, like, I'll work on that other code. Oof, be careful. That's where you gotta be careful. It's changing the formatting right there. It's changing how things are oriented, so watch out. This doesn't have to be perfect. There's no like huge style points. I mean, eventually we're going to get to in later courses. My goal with this new structure we're doing is to kind of have people focus on how their work looks and is their work visually appealing. But right now we're more focused on can we explain things like what does this output mean right here that we have this table and what are we looking at? Really, there's not that big of differences. And you know what's going to be interesting, Kayla? I want you to tell me, do you think when I run the associate function on this, do you think the p-value will be high or low for this? And let's go right here. Let's grab our variables. we're basically going to grab this, y tilde x comma data equals, and when you go down here, and I just drop that in, my y tilde x comma data equals, how do you think the p-value will be on this? Remember, the medians were 7. Both medians were 7. So what do you think? You might see it. Oh, you can't see it on the screen. Good to see you here, Leslie. What do you think the p-value will be for this? What do you think the p-values will be? Because remember you said both groups had the same, and look at this. Here is, you can make it bigger and it'll be better looking. There's both groups. They look very similar. So both groups are nearly identical. I mean, they are identical in medians. So will the p-value be high or low? You can actually see the p-values down here. So here, I'll show you what the p-values are. Exactly, Kayla, you're 100% right. The p-values are extremely high. Look at those huge p-values because the differences between Greek life and non-Greek life, and we're only comparing medians right now, the differences between Greek life and non-Greek life is probably just due to what? Like, the differences between these two groups and how long they sleep with medians, because these don't look so normal, are probably due to what? And we've almost covered everything. I just need to cover this graphic right here and what's the deal with this. But these differences are probably just due to random chance. Exactly. And we'll remake the graphic here just so we can see it on like a larger scale. Let me kind of show the full graphic right here and just talk about it briefly. And then really we've covered almost all of the assignment. So hopefully it's seeming like this is not that bad of an assignment. Brian's kind of talked through most of it. We have 3. Hey, what's up, Alexander? So good to see you. We've only had 1 buffer issue today. So going up here to the very top, we have side-by-side box plots, because remember we're comparing 2 right here. So we're comparing side-by-side box plots. So that gives us a quantitative y and a categorical x. And so here we are with side-by-side box plots. Here's side-by-side histograms, basically stacked histograms. So exactly, Alexander. This right here, do you notice how this doesn't follow the red line perfectly? The better it follows the red line, the more we will use what? This is telling us if it's normal. And when it deviates from this, we would say it's not normal. So since we're calling this data skewed, i.e. not normal, like look at this outlier up here, that's that outlier. Since the data is skewed, Alexander, what should we use, mean or median? Since the data is skewed, should we use mean or median? We're saying this is a skewed distribution. It's got outliers and it doesn't follow the normal probability plot. You know this in 201 also. Median, great job, Leslie, exactly. And we'll see this actually in the second class this week for 201. Wednesday and Thursday for 201, we'll see this plot called a normal probability plot. If it follows the red line, we talked about this yesterday, it's normal. And if it's bent, this is 20-point Tuesdays. You couldn't be more right, Kayla. Let's do this right here. 20-point Tuesdays, winning out the lag right here. There we go, some 20-point Tuesdays. And so down here on the bottom, this is where people get confused. This is like our last topics right here. When you look at this right here, where are all these results coming from, Kayla? This is something I said earlier. This is how we're getting our p-value. All of these results down here, when we're doing the p-value down here on the bottom, are created by another p word like perm something. These are random what's down here at the bottom. This is not our data. This is creating a p-value. It's estimating the p-value for a test on averages. Exactly, Kayla. These are random permutations, and this is our result. And so this p-value, when we test the averages, should be almost very close to what? Can you tell like what percent of the results are pretty much as extreme or more extreme than this red line right here? It's going to be very close to what when we look at the p-value for this? Close to 1, exactly. And that's what I would ask people to estimate if we did it on a test. Because if you look right here at the p-value for this, let me see if the output will remake and it'll all be out good. And when you look at the p-value for that, like you said, perfect, Kayla, you said this p-value for this one was very close to 1. It's weird. I'm guessing that there's a whole bunch of results in here that we can barely not see. But don't worry, I like this one that I'd ask about. But all of these, no matter what, the p-values are very, very high. So the differences we observe between how much non-Greek and Greek life people sleep, the differences are probably just likely due to random chance. So would you say, so let me ask it in kind of a simple format, would you say that Greek life or non-Greek life people really sleep more than the other? We'll go back up to the results of it. It looks like Greek life people sleep 6.87 hours on average, and they have a median of 7. And then non-Greek life people sleep a little bit less with 6.86, just a tiny bit less with the mean. And the median right here is 7 for them. Same median. So, I mean, they do sleep a tiny bit less. We are comparing medians because the data is skewed, but all of these differences look to be by what? All of those differences right there look to be purely due to what? Like, I'd be pretty certain that those differences are just all random chance. We're pretty sure that all those differences are just due to random chance. Is this making sense what we're doing here, Kayla? And what's really super cool is you can analyze any variable you want with this. So if you have any variable like who brushes their teeth more, ooh, whoa, wow, not joking. And actually the mean is different because of the skew, but we pretty much just found something. There's differences in the means, but this is a highly skewed data set, and it's because of outliers right here. But who brushes, we know we'd compare the medians because of the skew and the medians right here, but what do you notice? And there's looks to be possibly, this is not statistically significant, but if you compare the means for how much people brush their teeth, Greek life versus non-Greek life, which the skew nature of the data is not what we should be comparing because it's skewed, but who would have thought it? And I just typed in a number, but it looks to be that there's probably something going on with, there's more variation in Greek life brushing their teeth versus non-Greek life brushing their teeth. That's just so interesting. There was another one. Oh, let's look at fastest car. Is there not a difference? There's no difference with fastest car. This is how quickly you can do data analytics. How much do people exercise? Oh, whoa. Well, there's no difference. I'm looking down there at the p-values. But data, how much people read? Nope, not statistically significant. Kayla, do you see, Leslie's laughing. Do you see, oh, it's saying it can't compute that one. Basically, we got a mathematical error where it can't compute how long people take showers for. I'm able to look at the p-values right down here because there's so much area to the right and find out that they're not statistically significant. I'm just going to keep running one until I find this one. Most miles run. That's not interesting. What percent people find dateable if they're in Greek life or not in Greek life? Not statistically significant. It's just so interesting to see how attractive people think they are. Not a difference. What are we finding out? Feeling hygienic today. You know what's interesting? What are we finding out about Greek life versus non-Greek life people? Like with all of these differences here that are not statistically significant, what is the moral of this story? All of these differences right here are coming out not statistically significant. Just explain to somebody like what this difference would mean. Ooh, this is different. This is different. Oh, we found a difference. We finally found a difference. It's not a quantitative. And what do you notice about this? Well, no, interesting, Alexander, with all the non-statistically, oh, but maybe you're talking about this. I don't know. With all the non-statistically significant things that we looked at, everything kept coming back not statistically significant. If you know how to look at this, you can actually see the p-value down here because it's the area to the right of the graphic. So all of these are coming back not statistically significant with the results. Just a quick, if you know how to read the graphics. But now we found something that is statistically significant. I paused on this one. I was able to tell the p-value right here. So people in Greek life, well, first off, most people use what to attract someone? What does most people in general use what to attract someone? What do most people use in general to attract someone? Like most people would use this or this to attract someone. We have other up here is pretty common, but most people are going to use what to attract a mate. Most people are using humor. We do see that Greek life is a little more likely to use humor and then also more likely to use looks. Does everyone see right here? Given someone is in Greek life, they'd be a little more likely to use humor and a good bit more likely to use looks. So we can look at the conditional distribution, which it gives us. So we have here, yes, Greek life, the probability that they would use looks is 30%. There's the 30% compared to non-Greek life is 18%. Do you see, and this is a review now, and this is also tool one relevant, how we can see the conditional distribution, which is going to be right in here. This is the conditional distribution, and here's the numbers. Here's the conditional distribution, and here's the numbers. And here's the marginal distribution, which is for all individuals. And these differences are large enough that we would say that these differences are unlikely by random chance. And that's why I was looking at this p-value right over my shoulder, because there's no permutations. Does this make perfect sense, Kayla? If you understand this, you understand, like, you're like a week ahead of us. Like, if you understand what's going on, that there's no permutations right here, thus the p-value is 0, we would not expect to see the differences up there likely by random chance. So that's unlikely that those differences would occur by random chance. Once again, most people use humor to attract people. Greek life individuals are just a little more likely to use their looks, or this is what they report. So it's all self-reported. Let's see if I want to look for one more. It's just so interesting to look at these variables and see the differences. Like, I just like looking at data. How many people have you dated? Greek life versus non-Greek life people have dated the same amount of individuals. How long have you been in a relationship? No difference there. I mean, they're really not that different. How much do you drink? Okay. Sorry, it's just the data. So this right here is all people not in Greek life. This is all people in Greek life. Is this data, I want you to look at the histograms up here, is this data skewed or is it normal? And then you can look at the normality plots right here. Is this data skewed or is it normal? This data right here, is it skewed or is it normal? Teaching in 33 minutes. It's skewed. So since it's skewed, which is also confirmed by the QQ plot, the QQ plot's going to be very important. Should we compare the means or the medians? Should we compare the means or the medians since the data is skewed? 201 question, very 201 relevant question. Should we compare the means or the medians since it's skewed? Should be instantaneous, right, Kayla? Medians. So I want you to look, the graphic right behind me is the median p-value. So what is the p-value when comparing the medians? And you can see the median here for Greek life, the median here for non-Greek life. And these people are outliers, and we have some outliers up here. It's how many drinks during a week. Nice job, Alexander. Close to 0. So we would estimate it to be 0. You're exactly right, Kayla. It's going to be 0 estimated to be, and the graphic is taking up so much space, we can't see it nice and easy on here. Let's just regenerate the output so we can see that the p-value is 0, and that's because there's no area to the right of this. Is this making perfect sense right here, that we see here that the median for non-Greek life is 1 drink a week, the median for Greek life is 8 drinks a week. And once again, this is just the way the data is. I definitely did not follow the trend right here of non-Greek life when I was in college. And my brother was in Greek life, and he's the one who's a pharmacist. He was closer to this trend over here. Once again, this doesn't mean what you are will determine who you are, because I did not follow the trend, and my brother did not follow his trend. My brother was Greek life. I was not Greek life. Make of that what you will. But this is the trend in the data we see, that, the differences between medians are super unlikely by random chance. It looks like there is an association between how much people drink and whether or not they're in Greek life. I know I'm not doing any groundbreaking research by telling you this. But once again, I want to always reiterate, individuals are individuals. I went against my trend. My brother went against his trend. And we see many people who go against the trend here for the no group, and many people who go against the trend for the yes group. 25% of individuals right here are basically having, I could look at them, did or that. I should be able to easily, this is a code you don't have to do. No, we want to apply. No, I want to use the aggregate. Let's go over here to the aggregate. Let's go grab the data, and I can easily change it. So if you look at how my code's written, let me go right here. You know what we could do? Watch this. Don't make this change I'm about to make. I'm destroying the output. What will this do? Cool. Oh, it does. Oh, I broke it. We'll worry about that another time. I had to sit down and write this code. Can I not just change this to summary? Okay, that worked. It does. Good. Then let's remove off all of this. And let's put here output. And let's run this. And there we go. That's way too much output though. Okay, let's rename the table names. And there we go right there. Output. Yeah. So then, it's calling it output. So let's just call this O. So, and then there's O min. There we go. So there's the, I don't know if I were to just, can I put a blank right there? Sorry, it doesn't like the blank. Let's call this drinks. There we go. Is there a way to learn some analysis program before taking this class? Like, yes, Jacob. Let me see if we still have spots, Jacob. And it looks like, did we only buffer once during this video? I'm gonna head off here and start to one. Jacob, email me about that, and I'll put you in some direction to some stuff. And maybe I'll see how many seats we have in data camp. Only once. We can take only once. We can do it only once. And it was only one. It was one big lag spike. We're good. Presley, good to see you here. Let's throw some 20 points out. Yeah, no, Jacob, that's a really good question. And make sure to remember in class, ask me to mod you, Jacob, and I'll make sure to mod you. But these skill sets right here are really neat. And knowing how to write this code can really help, because if you notice, we can just do an analysis of the medians versus the means right here. We get all this information, and you can kind of see where people are at based on the box plots we had previously. Nice job, Kayla, right there. I love it. Man, people are Alexander and Kayla. I am asynchronous, so I don't always come to class live. Oh, Jacob, can you show up at the start of next class? So I'll tell you why. I never mod anyone during these because any random person could join and maybe come up with a name. I'm not saying you're not Jacob, but any random, dang it. I have this one rule that I don't mod people during open streams. But come in, if you ever join, which I'll be teaching one in about 30 minutes or 28 minutes. If you join that one, you could join for like a second, be like, hey, Brian, mod me real quick. And I'll be like, boom, got you, Jacob. Because that way I know you have the link to the unlisted stuff. So not that I think a person would really be like, I'm going to join Brian's streams just to become a mod. Yeah, no, I appreciate it. I paused and I was like, I just really want to mod Jacob. And great job, Jacob. Keep up the great work. We did tons of 320 today, going through some of the topics. And I think 201 has chapter 3 due tonight. We might come back and do that later today. But with that, I'm so glad we are not crashing today as much. Let's put on a little music here and let's end class. Today starts chapter 5, big topic. This is too sad. Let's go to this. Nice chill music. With that, everybody, be teaching here soon. Great job, 320. Excellent work. We'll be back. But as we like to say, bye for now. Bye, everybody.